All right, I want to start off today with a little bit of review of our exponent rules because this will help us on our lesson for today. So remember that when you are multiplying something like x squared times x to the fifth, when the bases are the same and you're multiplying, you add the exponents. So we get x to the seventh power. When you're dividing and the bases are the same, you subtract the exponents. So in this case, we would have m to the third power. Also, remember, you can think of canceling out this m with one of these m's in the numerator, which left m to the third power. When you have a negative exponent, remember what that means. The whole thing isn't negative. Negative exponent, you should think of the word reciprocal whenever you see a negative exponent. So this is the same as 1 over x to the second power. So remember that rule. Negative exponent means reciprocal. When you have a power to a power, you multiply the exponents. So in this case, this was like 3 to the first power. So we would have now 3 to the second power, which is 9. And x to the eighth power, because you're going to multiply. So that would be my answer for that. And down here, again, it's similar to number 1. The bases are the same, so you add the exponents. 3 halves plus 5 halves is 8 halves. And 8 halves is just the same as 4, so this is just m to the fourth power. All right, so just a quick reminder of all the exponent rules that we've worked with, and we're going to be using those today. So today's learning targets, I can write expressions with rational exponents, so that's going to be fraction exponents. I can write them in radical form and vice versa. And the other learning target today, I can simplify expressions in exponential and radical form. Radical form means you're going to have the radical symbol, like a square root or a cube root. Exponential form means you're going to write it with an exponent. So we're going to find how we can go back and forth between those two forms. First, what I'd like you to do is take your calculator and evaluate 16 to the 3 halves power. And you should practice this on your calculator as well. When you do this, you'll have, I'm going to have to mess with this a little bit. All right, so we're going to have 16. And to raise it to a power, you're going to use the little caret key. And we want it to be to the 3 halves power. If you want, you can do it like a fraction, alpha, and then F1. Choose the fraction. And we want to the 3 halves power. And enter. And I get 64. So 16 to the 3 halves power equals 64. Now, when you evaluate a rational exponent like this, and I've done some things with dates on the board. Let me have you try another one. Let's try. I'll have you try 9 to the 3 halves. So if we do 9 raised, and I'm going to just go 3 divided by 2 for 3 halves. And I get 27. What's taking place is on this fraction, I'm going to write it big because I'm going to list some parts here. This 2 tells you to take a root. In this case, it's a square root because it was a 2. And the 3 tells you to raise it to a power. So these are numbers we're familiar with. If you take the square root of 16, you get 4. And if you raise 4 to the third power, you get 4 times 4 times 4 is 64. Similarly, this is a root. Remember, roots are in the bottom, like a root cellar. This is the power. So if you take the square root of 9, you get 3. And if you raise 3 to the third power, 3 times 3 times 3 is 27. So when you have a rational exponent, the numerator of the fraction is a power, and the denominator of a fraction is a root, which means that I could write this in radical form this way. I could say it's the square root of 16 cubed. Remember the square root, I don't need to put a 2 here. I could if I wanted to, but this would be the square root of 16 cubed. And I could actually evaluate that on my calculator. If I do the square root of 16 cubed, I get 64. The same thing that I got when I raised 16 to the 3/2 power. So that's just a way of rewriting that. I could also write this as the square root of 16 cubed this way. Notice if I do this on my calculator, the square root of 16, then I'm going to go outside of the square root sign this time and raise it to the 3rd power. I get 64. So these are all equivalent. So this is exponential form. And either one of these is radical form. All right? So here's just a couple of quick examples. I'm asked to write a to the 1/6 power in radical form. Remember, 6 is the root and 1 is the power. So I'm going to have the 6th root of a. Now to show that it's the 6th root, I have to put a 6 here. And that shows it's the 6th root of a to the 1st power. I don't have to put the 1 there. I could just say it's the 6th root of a. And for this one, remember the 2 tells me it's the square root of m to the 1st power. So it's just the square root of m. So changing that, I was given it in exponential form. I changed it to radical form. All right, why don't you try these two? So a cube root would look like this, the cube root of a, and a 5th root of x. Those would be radical form. Now let's go the other way. This is asking me to do the 5th root of b. And notice this is like having, this would be like having b to the 1st power. So I end up with b to the 1/5. And for the next problem, this is the square root, w to the 1st power. So I would write w to the 1/2. So not too hard there. So go ahead and try those. So here we get x to the 1/4. Here we get y to the 1/3. Now unfortunately there's not an example on here. What about something like this? Well, if you were writing this as a rational exponent, you would just write x to the 2/3. Power on top, root on the bottom. Okay, now on this next one, we're going to have to remember what our exponent rules are. Remember what a negative means. Negative means reciprocal. So I'm going to flip that over. And what does a half mean? A half means square root. So I'm going to take the square root of 49, but I'm going to flip it over, so I end up with 1/7. So it's the square root of 49, but it's 1 over that. On this problem, this is a different type of problem. Remember, we're going to take, this is the root, this is the power. Now, it's much easier to evaluate the root first. So in this problem, the 5th root of 32, and you might have to try this a little bit, but you can check this out and see that 2 to the 5th power is 32. So the 5th root of 32 is 2, and 2 squared is 4. So that's my answer. You can evaluate this on a calculator by doing 32 raised to the 2/5 power oops, except it would help if you did, well, this is just not working too well. There we go. We get 4. So you might want to pause and try these. So in this one, the square root of 25, but negative tells me to flip it over, so I get 1/5. And on this one, the 4th root of 16 is 2, and 2 to the 3rd power is 8.